7.4, we're going to solve logarithmic equations. So you can see each of these equations has a log in it, and it says log base 2. Number 1 says log base 2 of 2n plus 7 equals log base 2 of 29. Now the first couple are kind of nice because the log base 2 is going to cancel itself out. And when you're solving an equation, if I had 3x plus 1 equals 13, let's say, you're trying to solve an equation, you're trying to undo operations. And so you undo the plus 1 with a minus 1, and then you undo this times 3 with a divide by 3. We know this, we see this over and over again. We undo operations to solve equations, but you undo a logarithm with an exponential. And so I guess the reason why this cancels out is because what we would do is we would raise the logarithm into an exponent. All right, we talked in the last lesson about how a logarithm is equal to an exponent. And so that's kind of the concept behind why this is going to cancel out. Basically, I make that whole thing an exponent for an exponential with a base 2. And you can skip that part if you want to, but I need to show you why it cancels out. All right, and once it cancels out, all you have left is the argument part. 2n plus 7 equals 29. And so solve this the normal way that we would solve any other equation. Subtract 7 and divide by 2. N equals 11. Now, the last thing you should probably do is just check your answer because this number or this number cannot be negative. And so if I plug in 11, I'm going to get a positive number, and that's going to be fine. That's going to work. Okay. So as we move on, if you look at number 3, basically the log 20s are going to cancel each other out, and we're left with 5. This equals this. 5m equals m plus 4. And so we've got like terms to get together. I'm going to subtract m. 4m equals 4. Divide by 4. Do that in your head. You're going to get m equals 1. M equals 1. If you plug it back in, you're going to get a positive number. You're in good shape. That's going to work. Only time you ever have to think about it is if you get a negative. Okay, log 11s cancel each other out. Negative x minus 4 equals 2. And we're going to add 4. So we have negative x equals 6. Divide by negative, or multiply by negative, I guess, either way. X equals negative 6. Now, from what I've said, that might not seem like it's going to work, but if you plug in a negative 6 right here, negative 6 minus 4, that's 6 minus 4 is 2. It's still going to work. Number 7, same thing. You're going to end up getting negative x plus 9 equals negative 2x minus 1. And so let's get our like terms together. Add the 2x over. That's x plus 9 equals negative 1. Subtract the 9. X equals negative 10. Okay. If you put in a negative 10, oops, not right there, right there. You have negative 10 plus 9. That's going to be 10 plus 9, 19. That's cool. If you have negative 2 times negative 10, that's 20 minus 1. That's 19. Okay, we're good. Good shape. So I think you're getting the picture. They're all kind of the same, number 9, until you get to 11. Let's do number 9, last one of these. These cancel out. 2b plus 10 equals 5b plus 4. I like to subtract or get rid of the smaller of the two variables. I just think it's more efficient that way. 3b plus 4, subtract 4. 6 equals 3b, divide by 3, b equals 2. 2, plug in a 2. You're going to get a positive number. You're good. Okay, number 11 is the first one that's different. So we have to change gears here, and we have to think about a couple of the last lessons. We have to remember that a logarithm is an exponent. All right, so in an earlier lesson, we really hit hard that a logarithm is an exponent. A logarithm is an exponent, so that means this. A logarithm equals the exponent. That's the exponent, number, the 2 right there. Okay, so basically what we have to do is think about what we always have to do in solving an equation is to undo operations, all right? And so if I'm trying to figure out what this x equals, I'm going to have to get rid of a times 2 at some point. So that means I'm going to have to divide by 2 at some point. But I'm also going to have to get rid of this logarithm. And how I get rid of a logarithm is with an exponential, all right? You cancel out a logarithm with an exponential. And so go back up to this step right here. The reason a log base 2 was canceling out is because I can take an exponential of base 2 on both sides, all right? So base 2 with an exponent of log base 2 is going to cancel itself out. I know that seems kind of weird and difficult at first, but basically all I'm going to do is look at this log base 4, and I have to get rid of that. So I'm going to raise it into the exponent of a base 4. So that whole thing right there is now an exponent, and I'm going to do that for both sides. That 2 is an exponent. So I've got 4 to the log base 4 of 2x equals 4 to the second. And it cancels out right here. Of course, it doesn't cancel out on the other side. We would still see the 4 to the second on the other side of the equal sign. So if you look at what's left after I cancel out the logarithm, I still have a 2x. I have a 2x equals 4 to the second power, or 2x equals 16. Divide by 2 and x equals 8. X equals 8. Okay, so we look right here and make sure if I plug in an 8, 2 times 8 is 16. That's positive. That's fine. That works. Okay. Next one. We're trying to solve for b, so that means we're going to have to divide by -2 at some point, but we're also going to have to do a base 7. So we start with a base 7. That cancels out your log base 7, gives me -2b equals 49. 7 squared. Remember that 2 is an exponent. Divide by -2, and we get some kind of weird fraction, but let's just leave it as a fraction. It's fine. b equals -49 over 2. And the reason I know that's going to work is because when I look here, -2 times a negative fraction is going to be positive. That's going to work. That's going to be fine. If you wanted to take out a calculator and figure out the decimal, -49 divided by 2, be my guest, but I don't need that. So once you figure out the pattern here, it's really not very hard. It's like, why are we doing what we're doing? Well, we're trying to cancel out the log base 3. We do that by raising it into an exponential. 3 to the log base 3 of 10n plus 1, that power, all right? And so we cancel that out. We're left with whatever that argument was, 10n plus 1 equals 3 to the 4th power. If you don't know what 3 to the 4th power is, you can always plug it in. Let's see, 3 to the 4th, 3 to the 4th is 81. Subtract the 1, 10n equals 80, divide by 10, n equals 8. Next one, get rid of a log base 4 with a base 4. Okay, that gives me -9x minus 9 equals 4 squared, which is 16. Add the 9 over. -9x equals 25. Divide by -9. So what? It's a fraction. Deal with it. -25 over 9. Last one, number 19, has an extra little quirk, okay? Think about it. if we are going to solve for this variable, we want to know what k is. We're going to have to get rid of this times 4 with division. We're going to have to get rid of this minus 7 with plus 7. We're going to have to get rid of this log base 5 with an exponential 5 to the something. And then we're going to have to also get rid of this times 2 right here in the front with a division. We've got to cancel out all of the operations in this problem if we want to isolate the variable. And it has to be done in a specific order. I like to think of it as whatever my variable is in the center of like some kind of candy, or the center of an onion, I guess, if you want. And we have to peel off the layers. And so one way to look at it is which operation is the farthest away from that k, and that's this 2. The first thing we're going to want to do in this equation, if we're going to isolate the variable, is to get rid of that 2. So I'm not going to do a base 5 on both sides. I'm going to divide both sides by 2. That gives me log base 5 of 4k minus 7 equals 4. And now it looks like all the other problems that we've already done. We have to get rid of a log base 5 with a base 5. That cancels this out, leaves me with just, let's put it over here, 4k minus 7 equals whatever 5 to the 4th power is. Now, maybe you know that one, 5 to the 4th, maybe you don't. Calculator says it's 625. 625. All right, great. Add the 7 over. 4k equals 632. Divide by 4. And 632 divided by 4. 158. K equals 158. Tough stuff. Good luck.